are the same, or that they are parallel, not necessarily congruent. They just run side by side. They're never going to touch. So we do those little arrows. And because these are the ones that are congruent, these are going to be the bases. So we're going to label this a B for a base, and this also for a base. Now, in a trapezoid, do those two bases have to be the same length? No. So can we just use the same number for these B's? No, we have to decide that they're different. So to decide that they're different, we use what's called a subscript, where we make a really small number off to the bottom. So we're going to call this B1 and B2 for base 1, base 2. And then we can connect the other sides. Alright, here I have a trapezoid. You guys ready for some math magic today? Woohoo! Math magic. Alright, in our math magic we have a big trapezoid. Which ones are my bases? The left and the right? The up and the down. Good, you guys are crushing it. So this is my base 1. And this is my base 2. If I want to measure the height of a trapezoid, where do you think my height is going to go? Is it going to go on the diagonals? Do I want the height to go slanted or straight up? Straight up. So I'm going to just imagine this going straight up here. So this is my height. Okay, so we can mark that on here. We can do that height. That's going straight down. We have that height. It's imaginary there. It's not actually a part of that. It's just if we put a ruler there, that's where we would put it. All right, you guys ready for some magic? I'm about to turn this trapezoid into a different shape right before your eyes. Give me 1 second so I can make sure I do it right this time. Okay, you ready? I'm going to do one cut here. See, it was a trapezoid. And now, what is it? A rectangle or a parallelogram. And what's the base of my parallelogram or my rectangle? How long would this whole thing be across? Good, B1 plus B2, we add them together, good. And how tall is this parallelogram or rectangle compared to the original? Originally it was the whole thing. Yeah, I cut it in half. That's how I knew where to cut, was I folded it in half. So to find our area, I like to start with that half, that idea I cut it in half, times our height, times, now normally in a parallelogram we would just do the base, but this time with this base, we combined the bottom base with that top base. And Michael said that we need to add, we need to combine them. So we're going to put in parentheses B1 plus B2. Okay, because with that trapezoid, we can cut it in half. And actually go either way. This way it makes a really nice parallelogram. I should have gone that way. Look at that beautiful parallelogram. Oh my goodness. Miss Morrell, you're amazing. Thanks, guys. Alright, I'm going to color code this with my green and my orange. Yesterday I used green for base and orange for height. So I'm going to do the same thing here. Just keep it the same. That way when we look through, we can notice how things are the same. So I used green for my base. So B1 and B2 are my bases. Remember, those are the ones that are parallel. And then my height is what creates that 90-degree angle with my bases. Okay, so if you're ever like, what the heck, where did this formula come from? It's because secretly this trapezoid is really a parallelogram, which is base times height. But our base is now B1 and B2 put together, and our height is only half the height it was before. Amazing! Alright, Miss Sawyer is going to be passing out a sheet. On that sheet there's a dashed line that you can cut. So you can do these two problems kind of side by side. I'm just going to glue these two problems right up and down.
So the top half is what we're looking for, and that's the trapezoid. That's what you want to do in first.
I'm noticing a lot of phones out there in the crowd today. Should put those away. Maybe as Miss Sawyer just passing this around and you haven't gotten it yet, I get that, but make sure you have everything written down. We're going to do these two problems. You're like real late. Alright, so in this first one, the goal is to figure out what is our bases and what is our heights. So in this first one, let's just label which ones are the bases, which two sides. In this first one, 6 is 1. What's the other? 7.2. Good. Okay, doesn't matter which one is which. Do you guys want base 1 to be on top or base 1 to be on bottom? Put it on top? Cool. Base 1, base 2. And what is our height? Three inches. Good. I thought I heard someone say 2. I was like, what? Okay, so I'm going over to my formula here, and I'm just plugging in the parts that I know. So I'm going to say A equals 1/2 times, and I'm going to start with my height. What was the height of our trapezoid? 3. Pamela, do the problem. Alright, and then I have my base 1 plus base 2. And what is my base 1? What did we say? 3.6 plus my base 2, 7.2. You want to take time to color code that. If later you're going to look at this and you'll be like, what the heck just happened? Maybe write above this really small an H for that height. And this B1 and B2. So that way you're like, oh, I see where we got that from. That's also why color coding helps. Okay. Now we can put that in our phone, or not our phone, but in our calculator, which I'm going to put in my phone because I have decimals on my calculator. Here's the thing is, according to my order of operations, what do I actually have to do first in this problem? Yeah, I actually have to do that adding first. Why does adding come first this time? Yeah, they're in parentheses. So if you're using your phone calculators work really goofy with parentheses. So even if you tip your calculator sideways, you see those parentheses. I always get really confused. If you're just typing it into Google, I've been noticing a lot of people are just opening a new tab and typing it into like that search box. make sure that you actually put in, yep, 3.6, thank you. Make sure you actually put in the parentheses if you're typing it into Google, okay? And we get 16.2. And what are we measuring this in? Inches, just inches? Square inches. So we have a couple ways to label that. We can either do the SQ for square, so SQ and then IN. We could do the inches with the 2, or we could actually write out the word square. What do you guys want? Inches with the 2? That's normally how we write it. But we say square inches, which a lot of you are doing a great job of. Amazing. Alright, next up, same idea. First thing we want to do is identify our bases and our heights. Do our base to be the top and the bottom. Not always. But what do they have to be? They have to be parallel. Okay? So it just so happens in these two problems, they're the top and bottom, but some side and side. But they have to run coincidentally. It doesn't matter which one's B1 and which one's B2. It's your choice. You guys want B2? B2? Okay, throw that as B2. Switch it up this time. 2 is on top. B1 would be on the bottom. And the other thing I need B1 and B2. The other part I'm missing is H. H stands for height. And what is my height here? 4.9. How do you know it's 4.9? Why is it a side this time and not this weird in middle thing? Because it has the 90 degrees. Good. My hearing is getting better today, guys. Alright, so now we're just going to plug it in that formula. So we're going to say A equals 1/2. I always like to use parentheses, just that way it keeps things separate, and I know that I'm multiplying. I'm going to start with my height. Height is 4.9. And then parenthesis, and then I do my base 1 plus my base 2. So base 1, I have 3.2, plus my base 2, we said was 9.4. Now, if you worked ahead and you flipped those around, can you flip them around? Could we say 9.4 plus 3.2? Yeah, remember adding, we have that commutative property where you can switch the order. So 1/2 times 4.9 times 3.2 plus 9.4. Again, I really like to use Desmos because I can change things if I need to, and the last one I didn't type in the right thing, so I was able just to fix it quick. This time I think I got it right. So we got 30.87. And what does YD stand for? Yards. Who uses yards anymore? Just kidding. Summers use yards. Does anyone know, other than Gabby, how far is it down pool? How many yards? Michael might know too. He's a swimmer. How many yards is one lap down the pool? 50 is down and back, yeah. Yeah, 25 is down one. Fun facts. Except when I say swimmers swim in yards, they don't swim in a yard, they swim in a pool. But it's measured in yards. You're hilarious, Miss Morel. Thanks, guys. I try really hard. All right, here we go. Next one. We have kites and rhombi. Which, remember, a rhombi is really the plural form of rhombus, but because we're titling something, we want to use our parallelism, meaning if I make this plural, kites, and make rhombi plural, I want to say kites and rhombus, kites and rhombuses, but that sounds silly. All right, a kite is kind of like this goofy shape. I have a picture here, or I cut one out for you. All right, so a kite looks like this. We have two sides that are congruent, but the sides that are congruent are together. They're consecutive. And then the other two sides are together. So that's where we get a kite from. So try your best to draw that out. So this side is congruent to this side, and this side is congruent to this side. Alright, you guys ready for some math magic? Woo! No? Cool. A couple cuts to it, not just one. It's not as simple as that. Period 1, I tried making it as simple as that. Didn't work. I'm going to make this kite into 4 triangles. And then we know with those triangles, what can I make out of triangles? Rectangles. So there's a rectangle. And then I can put this right here. And here's a rectangle. One long rectangle. How amazing is that?
So amazing.
So amazing. Alright, but to get that, it's a little bit, I don't know, it's a lot going on. It's really hard to get it to look right. Alright, so it's not quite the same amount. And then we're going to use these triangles that are created. I don't know if I can even get this back to what it looked like. Like this, like this, like this. Something like this. So we cut them into these triangles. Okay, and these triangles go down the middle of the kite. So these lines going down the middle of the kites are called diagonals. For these diagonals, I'm going to use purple and brown. Actually, yeah, purple and brown. So I'm going to use purple for one and brown for the other. Okay, and what actually ends up happening when we create that that rectangle is that we're using half of that width. So we're going to say A equals 1/2. And this started off as this diagonal was the whole. When I flipped it, it ends up only being a half, and that's where we get that half from. And it's one of those, so half of diagonal 1. And then again, and then we have all of diagonal 2 being shown here because it goes from the top to the bottom of the thing. It's kind of hard without it being, that math magic was a little goofy. I'll go through it again better, color coordinated someday. Not today. Alright, so area equals 1/2 D1 times D2, and D1 and D2 stand for the diagonals. Alright, now a rhombi is kind of a combination of lots of things. It's a combination of a kite mixed with a parallelogram mixed with a square. So a rhombi is really similar, but all 4 sides are the same. So this side is congruent to this side, is congruent to this side, is congruent to this side. But we don't have those 90-degree angles. But again, we just do the same thing. We're going to do a diagonal times a diagonal. Alright, these other 2 shapes that you have, if they fit, you can go ahead and glue them in on this bottom part. If they fit, if they don't fit, you can just glue them in side by side. That's fine too. So if you're running out of space, go ahead and glue them side by side. They won't take up much work. If you have enough space, you can just glue it in straight up and down how it is. So if you don't want to cut yours and you just want to do yours up and down, that's fine. I was running out of space. Either way works here. Alright, these ones shouldn't take too long to do once we get them glued in. Again, I'm going to use purple and brown because it's different than our base and height. But we're looking at those diagonals from corner to corner. So in this first one, I'm looking from this edge, this corner here, all the way to the other corner. How long is that total length from end to end? Yeah, it's the same as this 15. The reason they labeled this 15 on top is because if I labeled it down here, it would have that end point of where they cross, and I wanted to show the whole thing is 15. So we had to label it outside of the shape rather than inside. So otherwise it would just remain this part or this part. So to get that whole amount, we put it on the outside. What's my other diagonal? Other diagonal we have is 8. So for our formula, it's A equals, or area equals, 1/2 times diagonal 1. What did we say is one of our diagonals? 15 times, what's our other diagonal? 8. Either if you want to think of it in your head, you might do 15 times 8 first, then do half, or you might think half of 8 times 15. If you're using calculator just does it for us, which is really great. Modern inventions, telling ya. 15 times 8 times a half, we get 60. So the area of this kite is 60 square, what does M stand for, miles? Nah, meters. Alright, now this time, this is a rhombus. Each side is congruent, so we can mark that with 3 tick marks if we really want to. 1, 2, 3, 1, 2, 3, 1, 2, 3. Alright, each side is congruent. But this time, the 12 is on the inside of that rhombus. It really only tells me from this corner to where the diagonals connect. That amount is 12. So if I want to find the full way across, how much is this other diagonal going to be? 12. How did we know this was going to be 12? Because the lengths are the same on the outside. And when it's a rhombus and the lengths are the same on the outside, our diagonals bisect each other. So because we have the 2 tick marks and 2 tick marks, we know they're the same. So diagonal 1 is going to be, what's 12 and 12 together? 24. Okay. Diagonal 2, we're looking for all the way across. So we're not just looking at the 10. When the 10 is on the inside, that only represents from the corner to the next intersection. So that's 10. I want to go all the way across. So I need to add those together. So this time it'll be 10 and 10, which is 20. Good. So our area is equal to 1/2 of one of our diagonals, 24, times our other diagonal, 20. Okay, if we want to do this in our head, I would do half of 20 first, because I know that really fast. What's half of 20? 10, and then 10 times 24. It'd be 240. So our area equals 240 square feet. And you might see that SQ, we didn't label anything like that. If you already labeled it with that 2, that's fine. But another way we can say that is by saying SQ and then FT, so square feet. Alright, there is a practice today. It's pretty short. It's 5 problems. The first couple of problems are going to ask you to go through your vocabulary and make sure that you understand parts of the trapezoid. And then the second 3 problems, you're just typing in kind of the formula and what numbers you